Hello, everyone. Welcome to today's meetup. And today, with manners help, I put together a presentation about manners. And this is generated based on a blog published by Manners, the first general AI agent. And they have shared lots of, I think, 6 key lessons learned from building this effective production AI agents that serve millions of users. So who is Manners? Yeah, go ahead to manus.im. So you can easily access it, right? And you can ask it to do anything for you. It can be generating images, creating the presentation, PowerPoint, or build a full stack web app, or analyze a spreadsheet. So this is like a very general agent that can adapt to many different type of tasks. And personally, I already subscribe to Manners and just for personal use. I don't think you can use it for enterprise right now. It's more like true customer use cases. Yeah, it all starts with the learning journey about how Manners is built, right? And Manners also mentioned that they learn these lessons through repeatedly rebuilds. They mentioned they rebuilt it 4 times. And also through thousands of hours, or even, I think right now, even more as it's getting more users of real world testing across diversified tasks. Yeah, I also feel like this is the right way to do an agent. You will never get a perfect agent right in the beginning. I think the key mental model is just release the agent, get it interactive with the users, start connecting feedbacks, figure out what works, what doesn't work, and just continuously rebuild or maybe improve the agent so that it can better serve your customer needs. So Manners also share their story, like the company overall originate from 2018, when it's more like an era of bird, kind of like a custom, just millions of parameters, a small transformer model, whether it is an encoder or decoder. So in the beginning of the Manners, the team still kind of decide whether they want to train an end-to-end model from scratch or just build on top of other frontier models. And then, yeah, so and then they find that, for example, if you need to develop lots of custom model, the fine tuning could took like weeks per iteration, and it may not apply very well to the fast moving applications, especially for the new product, right? Like the new product, you just want to have put together a very quick prototype and to see whether it fits markets. Especially for the fast moving product development, it's the slow feedback loops are not ideal, and the customer may not choose Manners for that. And then like around like 2020, like large models come into place, right? And then the in-house trained models became irrelevant, uh, given that the big models kind of can solve majority of the task there. Like you may not need to have all the in-house trained models. And then these models mark the beginning of the in-context learning. So this is also a hard lesson learned that previously, like trained models such as information extractions, semantic search, or maybe translation, right? All those models become obsolete or irrelevant because the large models are so powerful that the performance is much better than the in-house models. And basically, the custom ones they have developed in the past become falling behind there. And then the team is pivoted to choose context engineering over training models. And then because it's focused on context engineering, then they can shift the improvements much faster in hours rather than weeks of fine-tuning a model. Yeah, so the context engineering, actually all the lessons learned is about context engineering for Manners. It enables hours, not weeks of iterations for improvement, right? You can think about it, the AI era is like there's a tide here. So basically the Manners choose to be the boat on over the sea, right? Not the pillar stuck to the seabed. What it means that the LLM is kind of like the sea, or the waves, right? So if there's a rising tide, the boat is also going to be rise higher, right? So it won't kind of like you need to redevelop a boat because the tide is higher. But if it's a pillar stuck on the seabed, like it's cannot floating up due to the rising tide, then you are kind of just going to be buried like under the sea. So yeah, so then the models kind of pivot their strategies or put their bet on context engineering. And then they are able to ship improvements in hours. And they are going to they choose to stay orthogonal to the models, right? As long if the frontier big models improve, the manners will also improve automatically. So what they develop will always stay on top of the big models. And also like it also allows flexibility and make it faster to adapt to when the new capabilities emerge. Yeah. Okay, and then let's look into their bet on the context engineering, right? To understand that, maybe let's first understand like how the AI agent works. So usually this is the kind of very kind of standard process or user workflow with the AI agent, right? So the user provides an input or instruction, just as what I put to manners, like I want to create a presentation. And then the agent selects the action from, it may be predefined from the tool list, right? Or some like a prior knowledge that the agent has been equipped. So the agent is going to select action as a response to you. And then the action is executed. Manners has a virtual machine sandbox. So basically it can use just like the cursor, right? So it can basically use its own computer or browser to open a web page, to click on the website, just like cursor, and also can run the command line. Then the action is executed. And then the execution will produce the results, right? And also feedback, such as if there's an error there, it's going to provide the response to the execution. And then the action and observation are appended to the context. Because usually in reality, it's not like a one single term. It's not like just one single Q&A, right? So usually in this general AI agent, it's a multi-term. Multi-term means like you ask a question, you observe a response from the agent, you provide the second question or second instruction again to the agent, and the agent is going to respond back again. So it's like a multi-turn. And then all the prior list of actions and observations are going to be appended to the context. And then this will goes on and on, right? Until the task is complete. And then the manners basically fulfill the job for you. And they also share something interesting, that the average the tool cost per job is around like a 50 tool cost, at least to answer the user requests. Yeah. So this is kind of the overall framework of what it looks like, right? And Underhood is like an agent trying to figure out, to understand the user intentions, trying to run all the tools in the sandbox environment it has access to. And then it's able to respond the response. And then it's going to keep tracking all the past actions and results in the context, so that it doesn't lose track of the prior already reached conclusions there. They mentioned they have rebuilt manners 4 times. It seems very straightforward, right? It seems like to me, like also I feel like, oh, like just building an agent, it seems that every agent framework is there. It's pretty standardized, but they share that it's not straightforward at all. So Manus rebuilt their full agentic framework 4 times. And every time, like after discovering a better way to shape the context better, more for better performance and also for lower costs. They also call this as their agent stochastic gradient descent process. Well, this stochastic gradient descent is not the deep learning gradient descent, the numerical one. This is more like a empirical one, right? So you want to do some, what is the best formatting of the context? You want to do some prompt fiddling, some guesswork of, okay, whether this is the best prompt or best instruction to put there. There will be lots of empirical settings and configurations you can put in the context. And then you may do this multiple times until it kind of reach good performance for your customers. This is not theory, right? And also it's not elegant, but it works. Yeah, so basically this presentation, the blog mentioned that it just shares their local optimal strategies arrived after through this manual empirical process of building this agent. To the main dish for today, the 6 principles. So they summarize its own blog into 6 principles for building production AI agents. Yeah, so I think we are going to look into each sub-module in more detail. But overall, all the 6 ones, it's all about managing the context effectively. So let's first look into the first one, design around the KV cache. KV cache hit rate, this is the most important metric when you build an agent. So if you ever choose like one metric to optimize for production agent, KV cache hit rate is the most important metric to manage because it determines both the latency and the cost, right? And if we are not familiar with what is the KV cache, so KV cache is a technique to reduce the latency of generating a token by token output to you. So the key ideas under KV cache is instead of recalculating some values like Q key, right? So this is kind of how the attention scores are calculated using the queries and keys, right? So that you can get some weights and then multiply by the values. And then you got the kind of weighted values as the final attention scores for each of the tokens. So this is like how the attention scores are calculated underfoot behind the LM. Well, instead of every time you calculate all the values in the query key matrices, we can pre-store some values over here for the values, right? So instead of calculate all the value tokens or all the attention scores for all the prior tokens, we can basically just pre-store them over here. By pre-store is like you can trade in some memories instead of recalculating the values again, right? You can just focus on the new query tokens at each time step instead of recalculating the full matrices again. So this is like a very common kind of like a trick right now, I think enabled by almost every LLM to reduce the latencies. And also, if you look at the LLM API, they usually price much lower if it's cached tokens. So I think like if there's ever a chance to enable this, we'd better like enable this. And then the question is, okay, how can we put more tokens in cache so that we can increase the cache hit rate and lower the latency and the cost? So in their manus finding, they find like a 100 to 1, so input to output token ratio in the manus agent. So it's like 100 input tokens generate 1 output token. And on average, it's a 50 average 2 calls per manus task. And they also find about a 10x cost difference between cached and uncached tokens. And that is about 10 times like cost savings, right? So the cache token cost is like $0.3 per million tokens versus uncached is at $3, right? So it's like 10 times more expensive compared to the cache tokens. And also it improves the speed when you're generating a response to the users. So it kind of like a 5 times faster with when you with the KV cache enabled. So if you think about the production impact is massive. Because the manus, it's like processing, I think right now, far more than millions of tokens. So it's like processing lots of tokens daily, right? So if you're able to save like 10 times, the savings is going to compound like dramatically for the web, for the company to be profitable. Yeah. And then how can we increase the KV cache hit rate? So the first best practice is to keep your prompt prefix stable. Every token matters, right? So if there's any chance that you can determine a prefixed tokens, you'd better put it in the front of the prompt, right? So because the LLM is like auto-regressive, it means that it's always generating token one after another, right? Sequentially. So we need to make sure that put all the static information, such as the role definition, like the static prompts, such as the tool use, right? So the tool description, like make them all stay in the beginning. And then put the dynamic information toward the bottom of the prompt, right? So that all the previous static tokens are going to be cached whenever you send a request to it. So so this is a good format. And the bad format is, for example, you put something like system, like you want to track the time, like you directly put some dynamic tokens in the beginning, such as like a current time is going to change every time when the seller, not when the customer give a request, right? So this is dynamically changing and then it's not able to be cached effectively. We want to make sure that all the tokens, as much as possible, to be fixed in the beginning of the prompt. And also, if you change some token in the middle, it's going to have a cascading effect, right? So all the tokens after the change is not able to be cached. So which means that all the kind of the key values is going to be recalculated instead of directly retrieving it from the cache. So we want to more using this practice than every time, like every prompt is kind of updated on the fly. Yeah, so that's best practice one. Best practice two is due to that structure, right? To avoid the cascading effect, we should just allow a pen-only context and also indicate like exactly where the cache is going to break, like the explicit cache breakpoints. That is where the change or the token is changed, right? So never do not modify previous actions or observations. You just append the context to it. Because the users is also going to send multiple requests, right? So all the tokens appended will stay the same. You just add on top of it. So the context should only grow forward so that all the previous tokens can be cached. Yeah, so that's about the KV cache. It actually also, to my surprise, it's the most important metric to them. Because I saw like previously, I saw like maybe AI agent, the most important metric is the performance. Well, the performance evaluation data is very hard to get. Even I guess it's like even harder for a general AI agent. But like for manners, it's also interesting to see that they keep tracking and also optimizing the KV cache hit rate as the most important metric. And then the second lesson is about the tools, and it's counterintuitive. It's like more tools will make the agents dumber, not smarter. So basically, it's like if you are providing more tools in the context, the model is going to select. It's more likely to select the wrong action, and it may take inefficient paths. Right? Say if your task requires a sequence of tool calling. And if you have a very large space of tools, and then the agent could has a higher possibility of selecting the wrong tool, right? And then it's going to take not so efficient paths. So your heavily armed agent will get dumber when you add more tools in your context. And actually, they found that the MCP only adds fuel to the fire that the users can easily plug in hundreds of tools. Right? And they also show the performance, right? So the agent performance is going to drop, say almost 90% to just like a 30% if you just increase the tools from, say, the most relevant 10 tools to almost 500 tools as possible, provided the context. The performance is going to drop dramatically. So to solve this, well, the first intuition will be maybe let's just dynamically load in the tools on demand, right? But the drawback of that is going to break the KV cache because your context tokens are going to be dynamic instead of static or fixed in the context. And it's not going to contribute to the KV cache hit metric. That is the most important metric for them. And then how they solve this problem. So they propose to use this context-aware state machine to control the tool availability. So what it means, right? The bad approach is we should just dynamically remove the tools, right? We just load the tools on demand, kind of like the rack style, like kind of just always retrieve the most relevant tools based on the descriptions. But this will create serious problem. It's going to invalidate the KV cache. It's also confuse the model because all the previous observation reference are missed. And also it leads to the schema violation and maybe more hallucinated actions. Well, the manus solution is to mask the token logits. Rather than removing the tools, they actually provide all the tools, the fixed list of static tools in the context. So they keep all the tools definition in context to preserve the KV cache, because this is provided in the beginning of the prompt, right? So these are a static list of tokens, and then it's going to be safe in the cache. And then they use the state machine to determine which tools are available. So I will introduce what the state machine means. And then in the output generation, they can use the state machine to instruct the agent which set of tools to use when generating the outputs. So I'm going to share some examples next. Anyway, but the key principle is mask it, not remove it. This is also counterintuitive. I think this blog is very interesting. It's also saying like to control the behavior, control the agent behavior through the constraint decoding rather than to modify the context. So I will show some example next to explain what this is. What is the state machine? State machine, you can think about it as agent state. The state maybe originate from reinforcement learning, kind of like where the state is. Well, you can think about the state of the agent, right? So the agent state over here as the current state where the situation the agent is in, right? So maybe this is a state when it just received a question from the user, or the agent state currently is to do a web search, or the current state is to run a code execution, right? And then they define all the tools with certain prefixes, meaning that so all the tools related to replying to a user start with a message. All the tools related to browser or search, right, start with also prefix browser or search. And also for the command line execution or file system, all the tools will start with the exactly same prefix. And then you may wonder, okay, why these prefixes are helpful? And then, yeah, so basically this is the state and the tool prefix, right? So it is given a state, and then there will be a set of tools with a fixed prefix. Okay, then the next question is how this prefix is going to be helpful. I think it's a very smart way to implement this. It's like at the decoding phase, you can use the prefix to instruct the agent which set of tools to call, right? So there are also like a different mode over here. For example, if it's auto mode, means that the agent has the full autonomy to decide whether to call a function or not. And then the decoding part. So at the decoding part, you can also put some like a prefix tokens, right, to evoke the decoding. And then if it's the auto mode, you can just say the start assistant, and then the assistant can. Then the next tokens is going to be decided by the agent, whether it is a tool call or whether it's just direct message response, right? So it's fully up to the agent to decide what is the next token. And then if it's a required, which means under that state, Manus also configure as well, like if the agent is in this state, a tool call is always required. And then it can just directly set the prefix tokens for the decoding with the tool call, right? And then right now the agent needs to, well, basically the LLM needs to generate the next tokens right after the tool call. And it has to be a tool, right? Because the previous token is already a tool call, and then the agent needs to choose a tool as the next tokens or specified. So that's where the prefix comes into space. If you already know, like my next step is to use a browser, right? And I just need the agent just needs to decide which browser tool to use. And then you can provide the LLM like with the browser prefix. with and then the agent is kind of more constrained, right? Like the agent can only choose the next tokens that belong to a browser tool. So basically using the fixed prefix, you constrain the agent behavior by whether it's open or like a full freedom to do what's next, or like a full freedom to choose what tool to use, or only constrain it to select a browser tool. I think it's a very smart design here that you basically just pre-store all the tool description in cache. And then at the decoding phase, you have the state to tool mapping. And then you basically instruct the LLM to generate the constraint output with all the tool prefix over here. Lesson 3 is about the context window is never sufficient. I think Manus used the cloud model. I think previously it's like a 128K tokens. And right now, maybe it's a much larger context window, but it's not enough because first, the observation is huge, right? So all the web pages, PDFs, unstructured data, and the long conversation history can easily blow the context limits. And also, the performance will degrade, right? Like far reaching the context window limit, the model performance is going to degrade because of the attention mechanism. I think I also shared when I introduced the context engineering, like the LM will pay more attention to the beginning tokens and toward the end, right? The tokens toward the end. But it may lose attention in the middle. So the performance will degrade if you put lots of tokens in the context. And also the long inputs are expensive. Even with the prefix caching, you are still paying it, right? It's not free. So you are still paying it for every pre-filled token. So this is more like how the context window is. So maybe on top, there's still the system prompt and tool descriptions. And then you will have like a web page content, PDF, API response, database response, etc., etc. Lots of observations from the tool calling. And then you can easily hit the context window. So the performance is going to degrade, the cost is mounting, and also the context is nearly full. And then, so how can they compress the context? So, and of course, like the philosophy is like they don't want to lose any information. Even if with the compression, they still want to able to recover the original content if needed. So the solution, I think, is also, I think it's this time is straightforward, is to use the file system as the unlimited persistent context. So just use the file system as an externalized memory. And the agent should learn to when to write or read from files on demand and using it as structured storage. Yeah, so if you use the file system, it's kind of, well, it's still limited, but like theoretically, you can add more just hardware to it to make it unlimited in size. And it's going to be persistent by nature and also directly operable by writing and reading. And then compression strategies is like, it needs to be always restorable, right? Even if you shrink the context and save it in the file, you should not you should avoid like permanently losing information from that. So some restorable compression examples, such as the web page, if you already know the URL, there's no point of storing the full web page always in your context. And the documents, if you know the file path, yeah, you can just keep the file path and ignore the content. Only reread the website and contents when it's needed for specific operations. Yeah, so that's about the context. And then the next is how can we manipulate the attention to improve the performance? So this originates from the U-shaped distribution, right? So there's a loss in the middle problem with any LM, which means that the LM performs best with the information at the beginning and at the end of the context, but they're great in the middle. So if you put the same information in the beginning or in the end, the performance is going to be better But if you hide it in the middle of the context, the LLM may not even notice that, right? So for example, this is your kind of prompt. This is your context. You have your system prompt, you have your actions, etc., etc. And then in the beginning, the attention is high. And then when you move to the middle, the attention is going to be low. So if there's some important information in the middle, the LLM may not pay attention to it. And then when you gradually move toward the end, then it's like the LLM is going to focus a lot on those tokens. So basically, if the context window gets really, really long, and if your goal description, like what you want the agent to do, is somewhere in the middle or toward the beginning, the beginning, maybe the LM still remembers it, but that is a static list of system prompt and tools, right? Your goal may be towards somewhere mid-map here, like what the user wants the agent to do. And then like if the context start growing and growing, the agent may forget like what it's supposed to do. So the logic is the manus will create a to-do markdown file step by step, and it's going to always track what it's going to do next, right? And then it's going to checking off items as it progresses, and then recite it at the end, right? So because the last few tokens are the LLM is going to pay most attention to. So basically, it's going to retrieve the recite what you want the LLM to do again, over again, toward the end, so that the LLM kind of have a full attention to the task or to the goals. Yeah, so this is what the kind of it is about, right? So you have this, you have a sequence action observation. They find that at some point, it may lose track. So basically, you need to recite the objectives or to-do list again to the agent so that you can bring it back to the track, to the right trajectory. Yeah, so this is to, so manus will recite the objectives into the end of the context and then pushing the global plan into the model's recent attention span, right? So towards the end, so that the model will pay most attention to the most important information, which is the global objectives and plans. Okay, that's the lesson 4. And lesson 5 is keep the errors. Do not throw it away. They are the evidence and they are the kind of providing the implicit improvements to the LLM. So many times we will just leave the failed actions out of context instead of keeping them there. The manus think that it will be best to keep the error there so that the agent knows the full scope and knows more better the problem space. So when the model sees a failed action, it will implicitly, because you keep it in the context, it will implicitly update its beliefs and then shifts its prior away from similar actions, right? So the error shouldn't be just swept under the rug. They are the training signals, even though no weights got updated, but it will help reshape the beliefs and priors of the LM, of the agent, know like what doesn't work and make it less likely to repeat the same mistakes. And by keeping the errors in the context, the agent is going to be self-correcting through the exposures to its own errors. And it will also help the agent to better understand the task space. So usually the error recovery flow in manus, right? So there will be, say, it reads some file, and then the file not found. And then the model sees the error in the context and then update the beliefs about the valid file path. And then it is trying an alternative file path there. And then the error is kept in the context. And then the manus kind of know, oh, instead of reading this path, maybe next time I will just start directly reading from this path, right? Because I made a mistake in the past and know this path is not valid. And for the future actions, for reading files, I'm going to check this new path first instead of the errored one. Yep. So I think this is understandable. I think maybe like we should also like to save the context tokens, maybe we should also optimize, okay, what errors we should keep in the context and what errors we can remove. The last lesson, don't get few-shotted. Randomness is a helper. This is also counterintuitive because we usually say, oh, let's do lots of in-context examples, right, to instruct the LLM so that it can better learn what the task is about. But over here, it says that the LLM is just basically too powerful to mimic the repeated patterns. And if the context is full of similar patterns, the models will just follow that repeated patterns and will be no longer thinking. You will be no longer thinking, will be no longer optimal for the next actions or handling situations. For example, right, the task is to review the 20 resumes and then extract the key qualifications. Say you upload like 20 files to the LLM. And then the LLM like open it, read it, extract it, and save it. And then they do the same sequence actions over and over again. And then when it reach from the 15th resume, the agent is going to fall into a mechanical rhythm and say if you want to do something different other than open, read, extract, and save, like you provide some new instruction to it, the model is not able to sync very well to the new task. The model will just still continue the pattern because it's trapped in the pattern. I think this is a very interesting finding about the LLM, that is if you provide two repeated examples in the context, it loses the ability to think and adapt to different scenarios. And the model is going to be locked into the patterns, right? So, and then we need to break this rhythm with some variation, with some noise. So actually the variation and noise are good for LLM so that the LLM kind of keep their power, like maintain their power to think correctly, right? So some techniques can be, you can choose to use a different JSON templates, even if it's the same task, but just to keep as a variation, right? So we got, for example, the search, right? So say there are lots of search. You can choose different JSON formats and make it not repeated in the context. So type search, sometimes it's Q, sometimes it's query, and sometimes query is in the beginning, like this, right? So you basically, this is also counterintuitive because when we design the tools, we try to standardize it as much as possible. But Manus says no. Manus says like if you put too many standardization there, the LLM loses power. And then they design like many different formats of the JSON format, right? To perform the tool call or still alternative phrasing like queue, can be query, etc. So that the LM, keep stimulating the LM and keep it at the kind of the most powerful thinking mode. And sometimes you can also introduce some noise in the variations, such as white space, ordering, and structure, so that the agent can remain adaptable and context aware instead of getting stuck in this repetitive loop and cannot get out of there. I think this is a very interesting observation from Manners when they see lots of examples, real world examples. And it may also show that maybe for the tool calling or especially for the repetitive tool calling, maybe you want to have a different format there, and that can actually help improve the performance of the LM to get out of the repetitive rhythm. I think the sixth lesson learned from the Manners builder, the key takeaway is context is everything. The instruction, system prompt, always able to retrieve the web page and document when necessary. The user prompt, short-term memory, long-term memories on the file system, the available tools, right? And how we can make it a prefixed tool name so that we can enable the constraint decoding for the agent to choose which set of tools to use. So it's the art of providing all the context for the task to be plausibly solvable by the LLM. And it will matter a lot to the speed, right, of the KB cache, which will determine the latency and the cost, and will heavily determine whether that company is going to be profitable or not, or whether you can lower the cost for your use case. And also it will determine the accuracy. We see that providing lots of tools is not going to help with the performance. But with the tool masking, with the constraint decoding will actually help, like provide this state machine of tools, right? Will actually help help the agent to choose more optimal options and choose the right path to solve your task. And the errors are also important because it can help the agent to understand your space better. So maybe also keep what are the good examples of failures in context to help improve the resilience and also the performance of the agent. Yeah, and in terms of the scale, the context window thing, right, is always the limit. And also there's like the attention, like the U-shape attention of the LLM, right? So we need to make it selectable. Like you should have the flexibility to write and reread from the file system, and make sure that we always keep the most important thing toward the end of the context for the LLM to pay the most attention to.